Quadratic functions in contextual situations. When an object is thrown or kicked into the air, it follows a parabolic path. You can calculate the height in feet after t seconds using the formula h equals negative 16 t squared plus vt plus s. The initial velocity in feet per second is v, and s is the starting height of the object in feet. So let's apply this equation for a situation. We're told that a baseball is thrown straight up with an initial velocity of 50 feet per second. That will be our v in the formula. The ball leaves the player's hand when it is 4 feet above the ground. That will be s. At what time does the ball reach its maximum height? So we'll first start by writing the formula. We'll substitute 50 for v and 4 for s. And then because we're looking at what time does it reach the maximum height, we'll remember the way the parabola is going to appear in graphical form. The vertex is going to be the maximum point, because this will be a concave down parabola. And we're really looking for the axis of symmetry. That will give us the time. And the formula for the axis of symmetry when a quadratic function is in standard form is x equals negative b over 2a. So t, in this case, equals negative 50 divided by 2 times negative 16. Now we'll simplify this, and then we will simplify this fraction to 25/16. The ball reaches its maximum height at 1 9/16 seconds. It's not a good idea to turn this quantity into a decimal because it does not terminate quickly. So it's better to leave it in fractional form. In fact, 25/16 would be perfect. Try another example. This one is a soccer ball, and the height of the ball can be modeled with the function f of x equals negative 8x squared plus 24x. We're supposed to find the time that the ball takes to reach its maximum height. So once again, we will start with the equation that was given. We'll use the axis of symmetry, negative b over 2a. And that will be negative 24 divided by 2 times negative 8. That's 24/16, which simplifies to 3/2, so we know the ball reaches the maximum height after 1.5 seconds. Now we'll go on to a golf ball problem, and we have the equation that's given, where we can model the height of the ball, y, after t seconds. We're asked to find the highest point the ball reaches and how long it takes to reach it. So our equation is negative 16 t squared plus 160 t plus 10. And our axis of symmetry is negative b over 2a, so negative 160 divided by 2 times negative 16. That's negative 160 divided by negative 32, 5 seconds. It takes 5 seconds for the golf ball to reach its maximum height. Okay, so now I know the time. We need to know the value of the function at an input of 5 seconds. So here's our equation written in function notation. We want to find f of 5 by substituting 5 everywhere we see a t. And now we will use order of operations to evaluate the function at 5 seconds. So we know the ball reaches a maximum height of 410 feet, and it takes 5 seconds for the ball to reach the maximum height. We'll move on to a pebble problem. A pebble is dropped from a 256-foot tall cliff. And we have the equation that can be used to find the height of the pebble after falling for t seconds. We're asked to find the height of the pebble after falling for 2 seconds. So we'll start with the equation that was given. I'm going to multiply everything by -1 here to get my h positive. Now I'll add 256, and I want to find h of 2 by substituting 2 in place of time. That's -64 plus 256, that's 192 feet. So the pebble, which is dropped from a 256-foot tall cliff, after falling for 2 seconds, is 192 feet high. And we have a lava problem. A chunk of lava flies out of a volcano from a height of 12,447 feet at an initial velocity of 608 feet per second. Okay, so notice those two numbers are in our formula, our equation. And we want to find the highest point the lava reaches and how long it takes to reach it. So we will once again use our formula for axis of symmetry, -b over 2a. So that's -608 divided by 2 times -16. And we'll simplify this and we'll divide, and we get the lava reaches its highest point in 19 seconds. Now we'll go back to the equation. We'll write it in function form, and we'll find f of 19. And we'll use our calculator to get the highest point the lava reaches, which will occur in 19 seconds, is 18,223 feet. We have one last problem about acorns. An acorn falls from a 16-foot tall tree. So thus the plus 16 in the formula, the equation negative h equals -16 t squared plus 16 can be used to find the height of the acorn after falling for t seconds. So let's find the height of the acorn after falling for half a second, or 0.5 seconds. So here is the equation that was given. We can substitute 0.5 in place of t, and that's an equivalent expression here. Now we'll do the math, and we get 12 seconds, so we know the height of the acorn after half a second is 12 feet.